Hello there, and then welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. Now, in this lesson, we are looking at solving two-set word problems. And this is our introduction to Venn diagrams and the formula relating to Venn diagrams. So, without much ado, let's quickly look into it. So, talking of a Venn diagram is a visual representation of sets. You see, and then it shows the relationship between the sets. What you see here is a sample Venn diagram. Now let's look at the structure and then the various key regions. First of all, let's look at the universal set. So the universal set would include everything in the box. You see, so I've labeled that with the black box. Everything represented by the large rectangle and the subset of A and B, everything. It is included in the what? The universal set. Now, if you have two sets, let's say set A and then set B, if they are not disjoint, that is, if they have intersection, then this is how a typical Venn diagram is going to be. So first of all, you realize that everything in this larger circle here would be for what? A. You see, everything in this is what? A. Then on the other hand, everything over here as well is your B. Do you see that? Now, if you look at it critically, you see that they overlap. You see, and then I've painted that with a deep green. That is where we call the intersection. The intersection. Now, if I take all of A, but then I take out the intersection of it, then this side is called the A only. A only. So they are in A actually, but not also in B as well, unlike the intersection that are both in A and then both in B. That are both in A and B, sorry. Then for what we have over here, the very red one, that will be B only. That will be what? B only. Now, if you have to take all these two circles, then we are calling it the union of A and then B. The union of A and B. Now, what is inside the box but not in the union of A and B, we'll call that the complement of the union of A and B. So let me write the labels for you. So as you can see, this green aspect here is what we call the A only. A only. That is excluding what you have in the intersection. Then what you have in the intersection is the A and B. A and B, or A intersection B, as you see right here. Then for all of B excluding the intersection, we call it B only. B only. And then finally, for what is outside both A and then B, we call it the A union B prime or complement. With that said, let's look at the two-set formula called the Inclusive-Exclusion Principle that we'll be using to solve problems involving two-set word problems. Now, because of the fact that if you want to count the union of A and B, there is an intersection. You see this intersection here, which belongs to both A and then B. We would want to remove the doubling. Okay, because if you have an element and it is both in A and B, if you have to count them separately, you'll be getting a double. Hence, we say that the union of A and B is equal to the number of elements. So n of A simply means the number of elements in A. Okay, so the number of elements in A plus the number of elements in B, then minus the intersection of A and B. You see, and this is going to help us remove one of the doubles. This is the first formula we need to know for two-set problems. That is A union B. Now, what if there exists an element in the complement? If there exists an element in the complement. If there exists an element in the complement, then it would mean that our universal set, so U, would then be equal to the union of set A and B. All right. So the union of set A and B plus the complement we are talking about, because the complement is not 0. So this is how we write it, as I illustrated over here. You see. But if it happens that there is no complement, that is, if the A union B complement is equal to 0, then all it means is your universal set would then be just equal to the union of what? A and B. And that will be it. So with this said, let's look at how we can actually apply it in solving questions. So in the first question we have here, it says in a class of 50 students. So in a class of 50 students, it has been indicated that the universal set is equal to 50. Okay. 30 students study mathematics. So you can rewrite it as the number of students that study mathematics. So N of M is 30. And 25 study science. So the number of students that study science is 25. 10 students study both subjects. 10 students study what? Both subjects. We've been given the intersection as well. Looking at the subsequent question, it says we have to find the union. So that is M union S. Secondly, we have to find a student who study only one subject. And then finally, we have to find students who study neither. Now, to solve this question, we need to, first of all, illustrate the information we have been given on the Venn diagram. So taking time to draw my Venn diagram, this is how it's going to be. And I'm going to put my universal set here to show that everything in the box should be equal to what? 50. That is 50 students. Then I'm letting this black circle be my mathematics. And then the red circle will be my science, indicating that they are 25. And that of mathematics is 30. Now, when it comes to filling in the circles, we start from the middle. So let's start from the intersection of both. Looking at what we have here, it says the intersection, 10 students study both subjects. 10 students study both, so that is M intersection S equals what? 10. So we put our 10 over here. You see, so we have our 10 here. Then what happens to here and then here as well? Take note, you have said that everything in this black circle should give you what? 30. You already have 10 over here. If that is the case, then 10 over here plus a number here should give you your 30 here. And what number can that be? That is going to be 20. The same applies to here. We have said that everything in this red circle should give us 25. But we already have 10 over here. So 10 plus what gives us 25, and that is 15. Now, take note that since the question at one point would ask for the neither, and we don't have anything there, we let it be any variable of our choice. So let me make it y. And this would be our Venn diagram to solve the problem. Now, the first question says you have to find the union of M of the two sets. So the union of the two sets, that is M union S. Remembering our formula, we know that M union S. So union S is then going to be what? The number of elements we have in M plus the number of elements we have in S, this, then minus their intersection. You see, and substituting number of elements we have in M was actually 30, so we have 30 plus number of elements we have in S, which was 25, then minus our 10. So we are just applying the formula. This is, so with that, we would say 30 plus 25, giving us a 55. Then 55 minus 10 will give us a 45. You see, so in simple terms, it simply implies that the union of what? M union C, M union S is what? 45. As simple as that. Now, even apart from using the formula, you could see that if we take this over here, that is including this circle. So if you take this whole circle, that is the union of M and then S. You see, so if we add the element in this circle, it will also give us the same answer. You see, one thing is, as you continue to solve, you'd always come out with what? Easy ways and formulas. You can always be getting your answer. So 20 plus 10 plus 4, plus 15 would also give us 45. Okay, so let's go to the next question. The next question was where to find the students who study only one subject. Only one subject. Now, only one subject needs you to critically look at your Venn diagram. So when we are talking of only one, we know this whole circle represents mathematics and this whole circle represents what? Science. But in these two circles, since they overlap, we have three regions. This region here represents the intersection. That is, they study both mathematics and science. They are in both circles. This, on the other hand, study only mathematics and not science. This also study only science and not mathematics. So if you want only one subject, so only one subject, then that is going to be what? Only science and then only maths. You see, so only maths and only science. And only maths was a 20. So we have about 20 here, plus your only science, which in this case is what? 15. So plus 15. Adding that up gives us what? A 35. So it simply means out of the 50 students, 35 study only one subject. Do you see that? Only one subject. Now, the last question asks us to find the number of students who study neither. So neither maths nor science. And that is this portion over here we used as y. So how do we get that? Now, if you remember, we said if the complement is not 0, then it simply means our universal set would be equal to what? The union of the two sets. So in this case, we have M union S, then plus the complement, so M union S prime. And we already know our universal set to be what? 50. So we have our 50 equals M union S. Did we solve M union S? That was the first one we solved over here. And we had what? 45. So we come back here and we are using that 45. So it's equal to 45 plus your complement. So M union S prime. So it's now all about making your complement the subject. And how do we do that? We just bring our 45 to the other side of our equal to sign. So that we have 50 minus 45 being equal to what? Your M union S prime. And 50 minus 45 gives us a 5. So it simply means that our M union S prime, that is the number of students who do not study either subject or neither this nor this, is what? 5. And that is all as the solution to this question. In this lesson, all we have done is to look at the basis of two set problems and their basic formulas. And we have applied those formulas also to solve some questions. As usual, I'll leave you with an exercise that is just similar to this to test your understanding. So this here is your exercise. It says, out of 80 people surveyed, 45 like football and 35 like boxing, 15 like both. So you have to find how many people like at least one of the sports, that is F union B. Then secondly, you want how many people like football only, that is number of F only. Then how many people like neither, and then how many people like exactly one of the sport. With all, you've been given the formulas you need to use. That ends this first lesson on two sets problem. In our subsequent videos, we'll solve more questions just to enhance your understanding. See you in the next lesson. And if this is your first time and you think this channel will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now.